right, now what we're going to do is we're going to do another example, and this time we're going to use the Gauss-Jordan method. So remember, the only difference is we are, instead of going to row echelon form, we're going to go to reduced row echelon form. Okay, so not only are we going to want zeros below the diagonal, we're also going to make zeros above the diagonal. So that's the only difference, is we're adding one more step where we're going to want zeros above the diagonal, zeros below the diagonal, and only ones along the diagonal. Okay, so again, the first step is to write the augmented matrix. So that's going to be 2, -5, -21, 39. Then we're going to have 1, -3, -10, and 22. Then we're going to have 1, 3, 2, and -8. Okay. Now what we're going to do is we're going to put this in reduced row echelon form. So the first thing I'm going to do is I'm going to switch one of these rows with the second row, right? In fact, I'm going to put the, well, let me see, does it matter? No, it doesn't. Let's, yeah, let's just switch these two rows, right? So we're going to swap row 1 and row 2. So row 1 swap with row 2, okay? And so that's going to give us what? Okay, so I'm going to erase this, so make sure you have it in your notes. And so that's going to give me the following matrix. It's going to be 1, -3, -10, 22, 2, -5, -21, 39, and then 1, 3, 2, -8. Okay, now I want to eliminate these two as zeros, so I'm going to take -2 times row 1, so I'm going to do -2 times row 1 plus row 2 and replace row 2. And then I'm also going to take what? Negative row 1 plus row 3 and replace row 3. Okay, so row 1 stays the same, so that'll be 1, -3, -10, 22. This here, okay, so again, -2, so -2 times 1 is -2, plus 2 is 0. -2 times -3 is 6, plus -5 is 1. -2 times 10 is 20, plus a -21 is -1. And then -2 times 22 is -44, plus 39 is -5. Okay, so make sure you double check, right? So let me double check. So -2 times 1 plus 2 is 0. -2 times -3 is 6, plus a -5 is 1. -2 times 10 is 20, plus a -21 is -1, and then -2 times 22 is -44, and that would give me plus 39 is going to be -5. So that makes sense. Okay, so now I'm going to do the bottom one. So negative row 1 plus row 3. So that's going to be -1 plus 1 is 0. 3, right? -1 times -3 is 3. 3 plus 3 is 6. And then -1 times -10 is 10. Plus 2 is 12. And then negative 1 times 22 is negative 22, minus 8 or plus a negative 8 is 30. Negative 30. All right, so now the next thing, right? Okay, so now we're done with column 1. Now we go to column 2. Now with the Gauss-Jordan method, we want to eliminate this one and this one. So not just the bottom, but we want to eliminate the top. So now what I'm going to do is I'm going to take 3 times row 2 and add it to row 1, right? And notice that by doing it in this order, we never have to go back to column 1. Column 1 is done, and nothing in column 1 will ever change because of the way we're doing it. Okay, the order of row operations is making sure that none of the columns to the left change. Okay, so now let's see here. So we got, so we want to do 3 times row 2 plus row 1 and replace row 1. And then we want to do what? Negative 6 times row 2 plus row 3 and then replace row 3. All right, so what do we get? So now, what's going to happen here? The 1 is going to stay changed. Because these are zeros, 1 is going to stay the same. So then negative, or 3 times 1 is 3 plus negative 3 is 0. And then we do 3 times negative 1 is negative 3 plus negative 10 is negative 13. And then what? 3 times negative 5 is 15 plus 22 is 7. Okay. Now row 2 remains unchanged, right? Because that's what we're using to change the other 2. So this is going to be 1, 0, 1, negative 1, negative 5. All right, so now the third row, this is going to stay the same. The 0 is not going to change. And then negative 6 times 1 is negative 6, plus 6 is 0. Right? And then negative 6 times negative 1 is 6, plus 12 is 18. Right? So, so negative 6 times negative 1 is 6, plus 12 is 18. And then we're going to take what? Negative 6 times negative 5 is 30. Right? And we get 0, right? So negative 6 times negative 5 is 30, plus negative 30 is 0. Okay? And then the last thing we want to do, and we'll come back here, right? So I'll erase this, is now we want to take what? We want this to be a 1. So we're going to divide row 3 by 18. So we're going to take 1/18 times row 3 and replace row 3, right? So our final matrix, when it's all said and done, is going to end up being 1, 0, oh, hold on, we're not done yet. So 1, 0, negative 13, 7, and then 0, 1, negative 1, negative 5, and then 0, 0, 1, 0. Okay, now we're not done because we're using the Gauss-Jordan method, so now we're at the bottom. Now, if we were, okay, so anyway, I'm not going to say anything. So here now, the last step is now we want to change these to zeros. Now we're going to use row 3 to change these two entries into zeros. Okay, So now we're going to do what? Easy. Row 3 plus row 2. So we're going to do row 3 plus row 2 and replace row 2. And then we're going to do what? We're going to do 13 times row 3 plus row 1 and replace row 1. Okay? And so if we do that, just put it over here. Sorry, just not enough room. So now what's going to happen? We're going to take row 3 is going to stay the same, so that's not going to change. So it's going to be 0, 0, 1, 0. Now, we're going to add row 3 and row 2. So we're going to add these two, right? So these two are going to be unchanged, right? Because this is only affecting these. So 0, 1. So this is going to stay 0, 1. And then this is going to become a 0 because we're just adding 1 and negative 1. And then 0 plus negative 5 is still negative 5, right? And so that takes care of row 2. Now we're going to take care of row 1. So we're going to do 13 times row 1 and add it to, 13 times row 3 and add it to row 1. So in this case here, again, the first 2 remains unchanged. So this is going to be 1, 0. And then 13 times 1 plus negative 13 is 0. Okay, so now we've got our diagonal 1s and 0s here and 0s here. Now we're going to take 13 times 0, which is 0, plus 7. So this remains unchanged, right? Now, here is where we're done. Because what does this, remember from the very beginning? So this represents z, right? So x, y, and z. So this is telling us that z is equal to 0. This is telling us y is equal to negative 5. And this is telling us that x is equal to 7. And we're done. So when we put it into reduced row echelon form, it's solving everything for us so that way we can read the solution directly from the matrix. So this would tell us that the solution set is what? 7, comma, negative 5, comma, 0. And that's it. So make sure you practice using these methods, both the Gaussian elimination method and the Gauss-Jordan elimination method.